All right, we're going to find some of redundancy, I think, with the work we're doing. I'm starting out, you guys. Let's get going here, please. In our own words, we're going to find some redundancy with the work we're doing in Section 5.6. We're going into Section 5.6. I'm videotaping, guys. I'm videotaping and starting the notes. We're going into Section 5.6 with some triangle congruences already. We've got side angle side, we've got HL, and we've got SSS. Section, so side angle side, hypotenuse leg of a right triangle, and side congruence. So we're going into Section 5.6 with that already, those three triangle congruence theorems. HL is hypotenuse leg, the right triangle one from Section 5.5. So these are our existing triangle congruence theorems before we even start this work. Existing triangle congruence theorems. We have these already. Existing triangle congruence theorems. Now, going to our definitions here. Congruent figures, two or more figures with the same size and shape. Two or more figures with the same size and shape. And it's not even redefined in Section 5.6. It's just size and shape. Vocabulary that's coming along with us from working before. Rigid motion has to do with transformations that we can use on congruent figures. Rigid motion is just a transformation that preserves length and angle measures or size and shape. A transformation that preserves or keeps angle measures and length. And if it's going to preserve angle measures and lengths, it's preserving its size and shape. So rigid motions produce congruent figures. A transformation is going to be a translation, a rotation, or a reflection. Our slides, our flips, and our turns. A transformation that preserves angle measures and lengths. So we've got SAS, we've got HL, we've got SSS. We're going to go now and we're going to drop ASA. Angle side angle congruence theorem. Circle it up, write it up real large out to the side. ASA. Two angles on the included side of one triangle. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. I want you to notice this included side idea. I just highlighted with my marker what the included sides are. You could just take your pencil and just kind of put an arrow down there. That's the included side, and that means that it's between the angles. Between the angles. Angle, side, angle. It has to be between, just like the letter is in the name. So now we have one more in our pocket. We had side, angle, side, two sides and an angle in between. Now we have angle, side, angle, two angles and a side in between. And then and I don't even know how much I need to do in terms of notes. I think I just got this right here. If you take a look at our next one, so now we have SAS, HL, SSS, and then we have this one, angle, angle, side. If two angles and a non-included side, two angles and a non-included side. So I think about these like this. If I have my fingers here, and you can just watch, pair of congruent angles, angles, pair of congruent angles, angles, and then the side that they have in common. Angle, angle, side. So it really has to do, the way the letters are written really has to do with, so this one's just, what am I going to write down here? Two congruent angles and a non-included side. Two congruent angle pairs and non-included side. Angle, angle, and then the side. As I go around the triangle, angle, angle, and then the side. So SAS, HL, SSS. Now I have ASA and AAS. And don't forget that our HL that we had up here is the only one that's the special form of ASS. I'm not saying it in my video. The special form of ASS. No. No, you can't. Turn your page when you're ready to go on. I had somebody in a video note, like a response on my YouTube page, and it wasn't any of you guys. I have kids that subscribe to my YouTube page because I guess they have learned stuff from me, but a kid made a note, and I don't know who it was. Lady, you go way too fast. I thought it was kind of funny. So let's decide if we can use any of our theorems. So what I'm going to have you guys do at this point is when we start switching pages, let's just go along with what we know. We have SAS, we have HL. I'm going to write them up top. I got SSS, I got ASA, and now I have AAS. So I have 5 triangle congruences to choose from. We're going to look at all the things that we have for each of these, and we're going to decide which of the triangle congruences we can say proves that the 2 given triangles are congruent to each other. Decide whether enough information is given to prove that the triangles are congruent. If so, state the theorem you would use. What do you guys think about number 1? Let's start talking these angles here. Can I get you to work with me to write the congruent statement for these 2 angles that are marked? And what I mean by that is let's name these correctly. We're getting better at naming. We're getting better at naming. Go ahead, DJ. Oh, I don't know. I feel like maybe it could be. You're saying A, angle. I don't think it's angle. I think it might be an angle, side. I think it might be an angle, side. Angle, and then side, angle, side. I think it could be AAS. I'm just going to put that right there, but let's jot it down first. So how do I name these angles then? If I start out, let me get you going here. This would be angle JHK. Angle JHK. I have noticed in your work, some of you guys are still struggling to name angles correctly. And I want to remind you that when we name angles, the vertex has to be in the middle. So I'm naming this one right here, JHK. J to H to K. I need the name of this one then. J, I'm not using, nope, JKH is this one. This one right here. H is not the vertex. What has to be in the middle is K. Has to. GKH. There we go. Can you guys please remember that I'm making a video and the last thing we're going to do is videotape you arguing with each other? I'm sorry. It makes 0 sense. I appreciate you trying. You don't need to be fighting. So then I'm going to go, no, I have no problem with you trying. Just stop arguing. It's not an unreasonable expectation. Now I need to name this one that's sitting here. Oh, I like this one better. What can I name this one right here? I think I can just name it angle J. How come I had to use 3 letters on these others? I'm saying because the whole triangle is congruent. Honestly, the reason I used 3 letters when I was around K is because there's actually 3 angles going on at K. There's 3 different angles. It's the big one, the one I marked, and then this one. Whereas at J, the only angle there is HJK. J. If there's no other angles there, I can use a single letter. So I can say J is congruent then to G because there's no other angles coming in at point G. So there's 2 pairs of angles, angle, angle. I think I do have that angle, side relationship. Angle, and then the sides. I just have to make the statement about the sides. No, I don't even have to get into reflexive. I'm talking about these 2. I'm talking about these 2. GH is congruent to, the other one marked was KJ. So I thought that it could be angle, side. There's my pair of angles, there's my pair of angles, there's my pair of sides. Now I'm certain that it's angle, side. I'm certain that that one is angle, side. What does number 2 appear to be? Out of our choices here, I see angle, side, angle. I got this included side congruence. What do you guys think about this one? I didn't say 2 pairs of sides. I got a pair of angles, angle. I got a pair of sides, and I got a pair of angles. And if it's going to be ASA, it's got to be the included side. Is that the included sides? Sure is. Let me just look back. What did we say about included sides? The one that's in between the angles. ASA. So you know what? Let's not write them all down. I can see it by looking at it. That's ASA. If I had to do a proof, I'd be naming all those parts like I just did in number 1. If I had to do a proof, I'd be naming all those parts. Now, in this one, I'm looking at 3. I'm kind of getting a little bit ahead here. Let's see. JKL. Okay, I'm going to take my colored pencil, and I'm just going to highlight the 2 triangles that they're talking about. I know, right? So it's this one, and then MLK. So these bigger ones, but I'm highlighting. So the question is, oh, this one's interesting. I think there's a couple conclusions we can draw. I only got 1 pair of angles. I got angle M. I'm going to write it down right now. Angle J congruent to angle M. I got that marked. And then I've got sides. Oh, but you know what? As far as I can see there, boy, oh boy, that's just J to, I believe that's just J to N and M to N. Maybe I'm wrong. Let's go ahead and call it, you guys want to call it J to L and M to L, K? I think we should. J to L, M to K. We're not sure. Now the question is can I get another angle that's congruent? I feel like I probably could. I think I can do ASA here, and I'm going to talk to you guys about why I think that. And I'm going to start doing some things to this drawing that you might wonder, like, how do we have permission? We know some definitions is how we have permission. I know these angles right here. One second, sweetie. I know these angles right there are congruent to each other. How come? They're what kind? There's a name. Those guys are vertical angles. When I've got intersecting lines like that, angles that cross are vertical angles. Now, if these angles are vertical angles, I have to venture to guess then, oh, I don't think I have enough info. That's when I'm like, I'm trying to get down to some way. I don't think that there's enough information here. I'm trying to kind of reach and decide if I can get that angle K and angle L are congruent, but I just don't think there's enough info here. As much as I've just talked about, I don't think this gets me to being able to talk about these big triangles anyhow. You know, I started to think, okay, well, if I know this angle, and I was trying to decide, can I prove that this little guy right here is isosceles? I was trying to maybe prove that this side was congruent to this side, which would make these angles congruent, but I think I'm stretching at this point. Like, I just don't think there was enough information about the drawing. Now, how about number 4? Do we have hypotenuse leg? Because I'm asking on number 4 because I can see right off, these are right triangles. So with a right triangle, I'm going to ask myself, do I have hypotenuse leg? I know the hypotenuse of each are congruent. Do I have another leg congruent? I'm looking for this. Does this work? The hypotenuse SR and the hypotenuse VU, those are congruent. Do I have a pair of legs that are congruent? What are the legs of these triangles? You guys aren't sure? The legs are these guys. This is a leg. This is a leg. This is a leg. This is a leg. Do we have any of those pairs that are shown as congruent? So I don't have hypotenuse leg. Do I have something else? Can I use, I see 2 angles. I've got a right angle. Pair of right angles congruent to each other. I think it might be, Dominique, for sure. I got a pair of right angles congruent to each other, and I got another marking. Angle, angle, side. Yep, I think we can pull an AAS. pair of angles, then the sides. Not the HL. Even though this is a right triangle congruence, it doesn't mean that we're going to prove HL. AJ, get your head off your desk, please.
Is it the hypotenuse like if there was two sides that were congruent?
We would need to have a double marking on a pair of legs to use HL. So because the legs didn't have any congruence, I had to go see if there was another congruence formula that I could use. Now in this one, let's take a look at it. This is what I like about 5 and 6 is this forces us, and we've been getting better at this, to look at the way things are named. Our M and Q, number 5. So I'm not drawing anything. We're making a decision based on the given information. Do we have enough to prove these triangles congruent? Are they matching up corresponding angles? From the names, do M and Q match? Are M and Q positioned in the same place in the names of the triangles? So we've got a pair of angles here. Pair of angles congruent, and they match up here. You guys okay with that? How about N and R? Do those match up? N and R. Sure. Another pair of angles. I might have to draw this. We'll see. Now they have us looking at investigating N to L and R to P. N to L, R to P. Boy, I guess you know what the one thing that I need to know is this N to L and R to P. I got to draw this, you guys. I have to. I'm just going to sketch them both, put two triangles that look similar to each other. We're going to sketch them because I got to see if these sides are included or not. That's my trick right now. L, M, N. And if I'm going to order my name, L, M, N, I've got to start over here, P, Q, R. I was trying to do it from the way it was written, but I best do it just from, I'm going to draw another one down here. Might as well get ready for number 6 too. Same thing underneath, L, M, N. And I'm naming them based on the way that they were ordered, and I'm just trying to be consistent. We're going to decide if they're congruent regardless of how our pictures look. We'll use markings. Now, let me get back and focus on number 5. I'm going to mark off some stuff. We said M and Q. Mark that with a single. M and Q marking with a single. N and R. N, R, marking them double. We were told they're congruent. I'm marking it off in my drawing. I like this problem because it gets us like having to actually sketch to think about this a little bit further. And then they tell us N to L is congruent to R to P. I think these are congruent. What rule gives us this one? Pair of angles, pair of angles, pair of sides. And I've got to name it as angle, angle, side because it's the non-included angle. I got to name it as angle, angle, side because it's the non-included angle. Number 6, the order looks a little funny to me, so I'm just going to go by what they're telling me and mark them here. Number 6, the order looks funny. What do you guys think about L and R here? They're telling me they're congruent. L and R. They're not positioned the same, but I can still put it. L and R. M and Q. Put a double mark on M and Q. And then the last marking that I can put on number 6 is L to M. Oh, that's the included side. Is P to, oh, take a look. Are markings positioned in the same place from triangle to triangle? No. Like this, the triangle L, M, N, the markings go with the included angle, but the way the markings are over here, it's not about the included angle. So what do you guys think about these? Are they congruent? No, they don't have they don't match in terms of, you know, having the pairs go around the figures or go around the triangles in the same way. So these guys are not congruent. Not congruent to each other on this one. One last proof. Ooh, they're telling us to use ASA. In number 7, they're telling us. So I'm going to come down to the bottom of 7 and I'm going to put my last line of my proof. Triangle ABC has to be congruent to ADC, and I have to show it by angle, side angle. So this is setting me up to say, in my proof then, I've got to go down with some statements that wind up leading me to angle, side angle. Pair of angles, pair of sides, pair of angles. So I'm setting up by my last line, where do I have to get to? And now I'm going to go back and start looking at the given. I see my side. I'm going to put some letters out here. I want to talk about angle, side, angle. I see my side right now that I have to talk about. It's this one. Those two triangles share AC. How do I say AC is AC? What property allows me to say AC is AC? It is what it is, the reflexive property. Now I got to go figure out, and I set them up this way because it tells me I have to use ASA, angle, side, angle. So now the question is how do I show these other angle congruences? So I got to dig a little deeper in the given. In the given, so I just popped that reflexive out of there myself. I needed a side pair, and I went, well, they share that side, might as well use it. It was, yep. AC bisects. Okay, now here we got some useful information. Segment AC bisects DAB. That means this angle right here and this angle right here are congruent to each other. That's the angle I'm talking about it bisecting. So that just created for me my first pair of angles I can talk about congruence. Angle BAC is congruent to angle DAC by the definition of a bisector, and I was given that those were bisected, bisector, and that was given that they were bisected. So I just drew the conclusion that they're congruent to each other. A bisector splits them in half. Definition of a bisector. And then we also are told that AC bisects DCB, so it makes these, I see my ASA now. That AC coming through the middle also bisects this. We call this a reflex angle. So here's my other pair here, DCA. Angle DCA is congruent to angle BCA. And I'm right back with definition of a bisector, and that was given. Now, the reason I wrote them the way that I did in setting this up, like when I started my proof, I wrote down what I was trying to get to. It led me to figure out how I had to set my proof up. When I knew it was ASA, I came over here and I started looking. Can I find my angle side, included side and angle relationship in order to finish my proof? So it's all just about justifications.